everyone, welcome. In this lecture, we will talk about compound data structure. So, in the previous lectures, we already learned about simple data types, for example, numeric types, integer floats, then text data types, for example, strings. Compound data structures, uh, for example, lists, tuples, dictionaries, and sets. So, these are actually multiple items grouped together under a single variable name. And this compound data, they can be categorized as either sequenced or unsequenced, or you can say like ordered versus unordered data. The sequenced data structures are the ones that store multiple elements in a specific order. So each element is assigned an index based on its position, and we can use these index values to further access those elements. For example, lists, tuples, and strings. So these are the sequenced data structure example. On the other hand, the unsequenced or unordered ones, so they do not remain any specific order of elements, and these examples include dictionaries and sets. Compound data structures can also be classified as mutable or immutable. The mutable ones, these mean they can be changed, modified, or updated after creation. And these examples includes lists, dictionaries, and sets. On the other hand, the immutable ones, they cannot be edited once created. An example includes strings and tuples. For this particular video, we'll talk about compound sequence data structures and learn ways to manipulate them effectively. So first, we'll talk about list. List is a group of elements or items. It's separated by commas and enclosed within square brackets. And usually these items are of similar data type. So either they are a group of integers or a group of strings, or sometimes they can be compound data. But if you want, you can also mix the data type within the same list. And these lists are ordered, which means the elements retain the sequence in which they were placed, and these lists are mutable, meaning that these items can be edited as necessary. So using a range of inbuilt Python functions, for example, this append function, extend function, insert, remove, sort, reverse, or sorted, you can modify any item on the list. Here you can see some examples. For example, the first one is a list of integers containing all the prime numbers in between 1 to 30. The second one is a list of float containing some temperature values for specific days. And the second one is a list of strings. So it's containing some city names within the Virginia state. The last one, as I said, it's not very typical to have a mixed data type list, but you can have something that like a list that contains both string, float, as well as integers. And these items, they do not necessarily have to be unique. Sometimes the item values can be same as well. For example, if we create a list of all students' age in a class, some students can have the same age. So in that case, those age values will be repeated, as you can see here. And to get the total number of items on a list, you can use this length function. This length function is also applicable for other compound data structures, for example, tuples, dictionaries that we're going to learn later. Here you can see that I called the length function, and inside I put the list name, which is age, and it's returning that there's total 9 items within this age list. Similarly, in the next one, it's saying that there's total 7 items within the Virginia cities list. Since these lists are sequenced or ordered data, which means all items in the list are indexed. And this index, this refers to the position of an element within the list. And the list indexing, it starts at 0 and increases in ascending order from left to the right. So here you can see an example list that contains 5 elements, and the first element, the leftmost one, are assigned an index 0, and then the next one is 1, 2, 3, 4. So it goes on. If you want to access elements from the end of the list, so in that case, you can use the negative indexing. For example, here, like when you are using negative indexing, the last element is indexed as -1. In this case, this last element, 9, is assigned index -1, and then the counting continues backward in descending order of negative integers. So the second last element is -2, the third last element is -3, and it goes on. And here you can see, so in this first line, I'm printing the first element of VSCTs list. So I'm saying VSCTs within this square bracket, I'm putting the index position 0. And in the next one, I'm printing the fourth element of VSCTs list. So VSCTs, then index position 3. Now, say you want to know the last element of the list, and you can do this two ways. If you already know the length of the list, then you can calculate index of the last element as list length -1. In this particular case, like VSCTs, it has 7 items, and so the last item index will be 7 minus 1, which is 6. So if you print VSCTs, then index 6, it will print the last item, which is Dover. Again, like to avoid all of this length calculation, you can just use the negative indexing. So if you call like VSCTs, then within the index, you can say -1. It's returning the last element of the VSCTs too. Now, if you want to know the index of a specific item within a list, you can use this dot index function. For example, in this case, say we want to know what is the index position for this Bedford value within the VSCTs. You can say like VSCTs dot index, then within the parentheses, put the value, which is Bedford, and it's returning the index position, which is 2. These indexes are very useful to manipulate the list. You can use the index numbers to create a subset of the list. You can replace or remove any item at a specific position or iterate through the list elements. For example, like using these indexes, you can slice any sequence data. So in terms of list, this slicing means creating a subset of the original list. And all slicing operation returns a new list containing the specified elements. To create this slice or this subset list, use the index positions by writing the list name, then followed by a square bracket containing the start and end index values, and those start and end index values will be separated by a colon. And when slicing, the Python will always include the element at the start index, but exclude the element at the end index. So first, just to remind you, like I'm printing this VSCTs list so that you know which elements were included in the total VSCTs. Next, I'm creating this VSCTs slice, and I'm telling to printing the items starting from index 1, and then it goes on up to index 4, but index 4 will be excluded. And here you can see the whole VSCTs list and the sublist VSCTs slice here. And if you do not provide the start and end index values, the Python will use the default. So if you omit the start index value, it will use 0 as a default. If you omit the end index value, it will use the size of the list as a default. For example, in this case, so I'm creating a new subset and I'm omitting the first start index values. So it's returning the items from the beginning to index 4, but index 4 will be excluded. In the next one, I'm creating another subset, but now I'm omitting the end index values. So in this case, it's returning from index 3, which is included, to all of the values we have up to the end. And then in the last one, so another subset, and it's returning the items from the second last values, which is included, and all the values to the end. And here you can see like how this printing varies. We mentioned that these lists are mutable, so which means like we can edit them and we can append values to a list using this dot append function. And the new value, all of this new value we append, it would be added to the end of the list. For example, in this case, say I want to add a new city named Bloomfield. So if I say vscities.append, then inside the parentheses, I put the new value. And then like you can see, this is my updated VS city, and this Bloomfield city name is added to the very end of the list. You can also replace items at a specific position because lists are mutable. And the item's placement or the item's index will be secured. For example, so in our case, you can see the name Bluemont is incorrect within this list. Now I want to update the spelling for this particular city name. We can just say that VS cities, then within the square bracket, its index position, which is the Bluemont's index position 3. And then I'm saying like replace these with this new updated value, with this new correct spelling. And then if I print the updated list, you can see in this one, the name Bluemont is corrected. And also its position, it's still at index position 3. So its position is still retained. You can also remove the element by using the dot remove function. You can just say like, okay, remove this specific value. In this case, I'm asking like, okay, remove this Bloomfield values. Or you can just ask to remove the value at a specific index. For example, I'm saying like, okay, remove the city name that's at index position 3. You can also concatenate list by using this plus operator. For example, say I have this one list uh, combining bunch of national parks and then other lists that also have like 2 national park name. And then I can say, okay, national park list 1 plus national park list 2. And it's giving me a new list combined the data or the values from both previous list 1 and 2. Next, we are going to talk about tuples. So these tuples, they are similar to list. They also contain a group of items or elements, but they are enclosed with parentheses. And similar to list, they are also ordered, which means they can be indexed or sliced. And the main use for tuples is for storing fixed collection of elements. For example, geographic coordinates to save any geographic coordinate location. Like it's very common to use tuple. Here you can see the coordinate of a location, the longitude and latitude. And given that tuples are ordered, you can also find their values based on the index position. For example, here I'm saying like print the value at index position 0. It's giving us the longitude. And the next one I'm saying like print the value at index position 1. It's giving us the latitude. However, the tuples are immutable. So you cannot further change the elements of a tuple once created. Here you can see that think that we have this latitude value incorrect for this particular location and we want to update that. So similar to what we did with the list, I'm saying like, hey, coordinate index position 1, change it to a different value. But now it's giving me an error. And it's saying like, okay, tuple object does not support item assignments. If we must need to update any element of the tuple, we just need to recreate or reassign the whole tuple. So for example, we can create an updated coordinate where we call the first longitude value from the previous tuple and then assign the new updated latitude value. So here you can see our updated coordinate. Lastly, we're going to talk a little bit about strings. I know I categorize strings as simple data types, but also you can think of string as compound data structure because it represents a string of characters enclosed in quotes. And given these characteristics, string can be treated as sequenced or ordered data, which means you can index or slice strings just as lists else and tuples. However, similar to tuples, strings are also immutable, so you cannot change or modify once it's created. Here you can see an example of indexing and slicing strings. So I have this string variable called text, and it says, okay, strings can be indexed and sliced. And to access individual characters within this string, I can just call some index position and it will return the output. For example, if I'm saying text within bracket 0, it's returning the first character, then text within bracket 8, so it's returning the character at index position 8. Same text -1 means returning the last element, last character within the string, which is this exclamatory sign. Similarly to slice, here you can see that I'm saying, okay, print the text within bracket 0:7. So it's returning the string characters from index 0 to 7, excluding the last one, of course. And also if I say okay, print text 15 up to the end, it's slicing the index, slicing from index 15 to the end. All right, so that's what we have for this lecture. And in the next one, we're going to talk about unsequenced data structures. So stay tuned. Thank you.